We are live, and I just need to do some things on my end. There we go. That's good. And live chat. Okay, so one thing you might want to do is zoom it a little bit, Snork, your IE browser. Just hit Control and move the mouse wheel up, and yeah, so people can see on the screen better, because it'll look big on your screen, but it also look big for people who are viewing the shared screen. So so I'll switch back since we'll head on to your math stuff when more people come through.
Okay.
But, I'll just kind of give you a brief overview of what to do as far as setting everything up on your own. So RingCentral, I'm going to, how do I, oh yeah, that's right. Advanced sharing options. So only host. Okay. So first thing is you already set up everything through YouTube live stream. You know how to get there, so that's
I
good.
hope I got everything set up.
Yep.
I'm at stream now. I have the RingCentral part pasted in there. I updated the date to the 24th.
Yep. So that's the first thing you do. The second part is pretty simple. It's just starting your RingCentral account or Zoom account if you get one or someone gets one, it gets shared. Hi Jenny. And then the third part is all OBS. So OBS is basically capturing outputs and putting it onto some server where there's a live stream occurring, and for our instance it's YouTube. So if you open up OBS, there will be a settings area, and within the settings area there's going to be a category called stream. So when you go there, there's a stream type, which is streaming services, which is what you'll choose. The service is, you could just choose YouTube Gaming. That automatically sets the server that you'll be going to. They know, OBS knows which one it is. It's using the primary YouTube ingest server, and so there's a stream key in there. So all you would do is copy your YouTube stream key, which is in your YouTube live stream. It's at the very bottom. You have to hit the reveal button and it'll show your key, and then you would just paste it into the stream key in OBS in the stream settings. So that part's done, and all you have to do then is just start streaming, and that'll pretty much get everything started. Now there's a lot of other details. For example, what's your ISP upload megabits per second?
I think it's 20.
That's more than fine. That's way more than me. And also, what graphics card do you use on the machine that has OBS installed, and your webcam? Which
I don't remember what I have. I know my webcam's a Logitech, but
do you if you right click on your desktop,
okay,
do you see anything like NVIDIA or AMD in the selections?
Let's see. I think this one is an NVIDIA.
Okay. Do you see NVIDIA control panel?
Looking for that.
You can do a search through your start key.
Let's go to my settings and start.
Yeah.
After a while, it gets hard to forget or remember what you have at each one.
Yeah.
Okay, settings, system. About.
The easiest way, if you want to know, is download a software called GPU-Z, and that'll give you information.
How fast does that take to get in?
Pretty fast.
Let me pull up a.
I could show. I'll paste to you the link if you want to download it.
I've got it coming.
Okay.
NVIDIA GeForce GTX 960.
That should be good enough.
Yeah.
So basically, the first time you do it, going through your own machine, and we can try it the next weekend.
Mm-hmm.
So everything will be through your end, but I'll just show you the settings to set up. So
Okay.
You can set it up for 1080p, probably 30 frames per second is probably fine. That'll probably just use up maybe 6 megabits per second upload, so you have plenty of room on that end. So it's just to see how well the video keeps up when you're going live. So if it's not working too well at 1080p, then we'll switch it to 720. So the rest of the stuff is just getting your settings right, and it all depends on what your current monitor resolution is and what your output resolution is going to be, and then also your sound quality. And
Yeah.
so that stuff is a little bit minor. The next part would be setting up your scene and adding your sources.
Yeah. My neighbors don't seem to use much bandwidth, so I think
All right. Do you share with your neighbors?
well, there's common pool. There's a bit when you're off MediaCom, they say that the 120 meg upload speed is all to you, but there is a factor they have for what your neighbors are using too.
That makes sense. All right. So that's it. So I will give you the host.
I need to kill that share.
I
Is it already killed?
I already did.
Okay.
So you have hosts. You can share. Now, if you want to prevent people from sharing, and just only you share stuff, see on RingCentral the bottom, there's the share screen, and just to the right of it, there's a up arrow. If you click on that, that'll give you extra options as who can share and whatnot. And
Okay.
also, when you get a chance, go to your YouTube live chat and give people moderator abilities so they can moderate the chat in case.
Now, in your live chat, does it usually show that you or your channel is the one logged in?
You.
Okay, because I was trying to give some wrenches out there and I couldn't.
If you do it through your YouTube live stream page, you can.
Okay, so I need to start a second stream.
No, you don't need to start a second stream. Your current stream is already going. If you go to your page, you'll see the live chat there.
Right, but that live chat's down the bottom right.
Yes.
All right. Is there another place to see the chat?
You can pop it out if you wanted to see it that way.
Oh, manage moderators.
Yes.
Okay. Oh, come on. Okay, approved users. There are no approved users.
When you see people in your chat, all you have to do is just on the very right of their name will be a vertical ellipsis.
Yeah.
Just click on that, and then
I get go to channel or report.
There's no other options. There should be. Can you share your screen real quick?
Sure.
For YouTube live stream page.
Yeah, just making sure there's nothing private up there.
There's nothing.
There we go.
There.
Oh. You see it?
Hey, Ellis. No, you gotta share your screen.
Oh, there we go.
All right. So, yeah. So, like, say right on Jenny Lynn's name, click on the vertical ellipsis. Ooh, that's weird. Oh wait, and you're logged in. Click on your settings. That settings wheel. Oh, that's weird. Try someone else. Try me real quick. Oh, I'm just showing Snork how to give moderator keys. Holy smokes. That's really weird. Why is yours doing that? Does anyone live chat know?
Yeah, I mean they're in there.
Yeah, I know they're in there, but it's just really weird that you're not able to. Okay, if you click on yours to the right of your settings wheel, go back up to your settings wheel. To your right of that, yeah, click that vertical ellipses. Yeah, manage moderators.
Still got it zoomed out.
Yeah. Let's see. Huh. I wonder if... Alright, scroll all the way down. There's more settings, maybe... I think those are all default, aren't they, huh? So that should be fine. So, I guess the only thing to do is go to the person's channel and paste them into the paste new moderator's channel URL. I don't know why it's like that for you, but it should be easier. Yeah, Stevie says it might be that you need a certain amount of subscribers to unlock being able to add moderators or something.
Oh, yeah. Okay.
Yeah. So if there's an issue with live chat, I'll let you know.
Uh-oh. How do I get back? Okay, just close that. Yep. And I should be back.
All right. So do you want to go ahead and start your math lesson?
Yeah. Hey, we got Aeolus here, who's probably more current in it than I am. Got to remember, this is going to be from 30 years ago for me. So as a physicist, he would be using this every day, and he should be much more familiar than I am. And he can point out all my mistakes, and I won't feel bad about it. So we have some people, right? Yeah. Let's get started. I am going to have to share a screen. Not share a screen.
We'll figure it. It's one of these buttons.
I'm not getting the buttons. Oh, wait a minute. I'm already sharing. That's what's going on. Okay.
People.
You should be seeing a circle.
Yep.
A perfect circle with a perfectly perpendicular line drawn, a set of lines drawn through it. Correct?
Mm-hmm.
Well, my eyesight's not that good. I'm getting old. Let's think of the interaction of the world as a bunch of waves. And the funny thing is, waves kind of act like circles too. It's all depending on how things are relative to each other. And the way I thought I would start is the circle is one of the most interesting things in the world, in the universe. So it's round. If I go to a corner, let's call this the 0 axis, the x-axis, and call this 0. That's 0 height from being vertically. At that point, if this was an acceleration, that would be the maximum amount of acceleration up. Well, I guess I shouldn't get into that. Well, anyway, we cross the line, and at the exact point the circle crosses 0. If the center of the circle is also on 0, the circle will be exactly perpendicular at that point. If it was a small line, it would be a small perpendicular line. If we went all the way to the top, there would be a flat line. And if we went all the way to the other side, there is a flat line down. So I'm going to start with something really confusing. One of the circles that we're most familiar with is called our planet Earth. If we think of it not as a sphere, but a circle. And one thing that we're familiar with is the length of a day. Now, let's ask the simple question. How long does it take the sun to appear exactly the same height directly above you every day? So from one day to the next, how long is that? Yes, 24 hours, correct? It's noon to noon, 24 hours. That one seem pretty good? Okay. How long does it take the Earth to turn 360 degrees?
Approximately 23.7 hours, I believe.
Yeah. 13,996 minutes. And there's 14,440 minutes in a day. So he got it correct. He's probably seen it before.
Yeah.
The Earth rotates relative to the sun. So when we are thinking of our day, we're thinking of how long it is before directly above us points at the sun. The sun goes around, or the Earth goes around the sun. So every day it moves a little bit. So the Earth travels farther than 360 degrees. Or no, I got that wrong. It's a little bit less than 360 degrees in a day. Did I get it wrong? Is it less or more? It's more than 360 degrees in a day, because that's why we have to have a leap day.
Right.
So what happens is, if you count how long it takes the Earth to spin 360 days or degrees, you're thinking about it relative to the stars. So if you looked at a star that's way, way away, it would appear about the same angle in the amount of time, 13,996 minutes instead of the 24 hours. But if you look at the sun, you have to add in the angle that we changed with the sun in figuring your amount of time. So the circle gets to be pretty amazing because it compounds in so many ways so quickly. And so we start having things about, well, degrees are kind of arbitrary. We just kind of picked 360 degrees to be a circle. And instead, what if we had a way of measuring angles that wasn't formed by any arbitrary measurement that humans make? So some wise people who like to confuse people in classes came up with taking the distance around a segment of a circle that is equal to its radius. And that unit of measure for an angle is called a radian. Then to make it easy for us, to go halfway around the circle is called pi radians. It's 1. And then to go all the way around is 2 pi radians. And if you think of the diameter of a circle, it's the diameter times pi. 2 pi. well, pi is 2r.
And that
so, or no, I got that wrong. The diameter is 2r. But once that is done, ratios can start being made and calculated. So on here, I have a yellow line and a blue line. The yellow line is the difference from the y-axis, and the blue line is the difference from the x-axis. And the ratio of the blue line to the length of the radius is calculatable by some really interesting math. And I'll jump to that next. Put that on this screen. And I don't want to bore everybody by going through all of the math. And mostly what I intended to do was give people the just a feeling that there are some interesting things out there. This is called a, well, it says Maclaurin series, but it's part of a Taylor polynomial. And it's an approximation of how to get these numbers to tell you that ratio that's assorted, that is associated with each of the angles. And they're kind of interesting because they're derived. The guy at Maclaurin was really interested in ones and zeros. And he figured this by the corners of the circle, the 0 degrees, 90 degrees, 180, 270. And he figured out a way to transform them into a series of numbers that you could add up. And what this means is that if you put in the number n into this equation and calculate out that piece, and then change n to a 1, calculate out again. If you add all of those up together, they come out to the sine of that angle. If you for the next feature, it was how the zeros. Just a second. Valerie, these so the coordinates on the circle come up with
Oh my God.
sorry, what am I getting too far?
Oh, all those Taylor functions.
Yeah.
Oh, so many Taylor expansions.
Okay, but the strange thing is how they come together. For the sine, you add them and subtract them as they come together. For the cosine, It all comes, if this, as you go around the circle, the relationship changes. So when the line is on the negative side, it becomes a negative, and these functions all relate to that. And it's like the entire universe is a wave. So, but by doing all these additions and calculations, as you can see, they can get a whole lot. And I've had to go as far as, I'm thinking to get 32 significant digits, I had to do somewhere close to 50. The problem comes in when you get past the point where you can't calculate factorial anymore, is a very low number, and the whole system starts to fail.
Or rather, our human capacity to imagine those numbers begins to fail.
Yeah, but I've only had one application where I've needed 32 significant digits.
That must have been one hell of a star chart.
Yeah, it wasn't a star chart. Well, anyway. Bond, did I go too quick on that one? But the baseline math that you do eventually starts to get useful. And it's how you make these out. It's like one of the things that I always wondered, like in 10th grade and whatever, is you're just going through endless things that don't have anything, don't seem to have any use, don't seem to have any relevance. And I think that kids need to be introduced to what they will learn to do with it earlier to understand. Alias, do you think that would have helped you? Do you think it would have helped you back in 10th grade knowing that it would be used like this?
It probably would have, but also you have to remember, I was in Oklahoma. We didn't cover Taylor expansions until my 11th year.
Yeah, we didn't cover it until college.
And I didn't even touch calculus until my senior year. And that was for an AP class. The only way I could get calculus.
So,
well,
Snork, so if you're going to give us one of the examples piece by piece in relation to a real world scenario, how would you explain that?
Well, this is actually what your pocket calculator goes through, except it has stored tables. They've figured out that these numbers for a certain bunch of ranges, and they store them in your computer in memory. I don't believe your calculator is actually calculated out step by step anymore. But this is how they derive all those numbers when you push in the sine of an angle. It's through formulas like this. So they all have a relationship to ratios of things that naturally occur in the world that are not human assigned. So they're all natural relationships. They give examples of it far better online than I could give. Other functions, things that are being used for calculating financials even a lot of times are Taylor polynomials. And
I'm trying to think if anyone have questions in live chat. Let's see. Oh, here's a good one. Well, someone was saying, like, a flat earther. I forgot who. I just read it real quick. So if the Earth was theoretically flat. Okay, that's maybe the bad example. If someone thought the world was flat or believed the world was flat, how would you be able to?
Sorry about that. I had a local disturbance.
No problem.
Well, I mean, there are several experiments you could do. I mean, aside from shooting them up into space to see it for themselves, there's an old experiment that was actually run during the time, I believe, of Alexander the Great, or very shortly after his period, where a Greek scientist was working in Egypt, and what he ended up doing was really clever. So he observed the shadow casted at noon from two different places along the Nile River. I believe one of which was about 500 miles or some 500 miles to the south, 250 to 500 miles to the south. And he measured the length of the shadows from these two spots. What he ended up finding was that the further up he went, north he went, when he was taking those observations, the more elongated those shadows would appear, would begin to appear. And so, using some very rough mathematical mathematics, he was able to calculate the circumference of the Earth to the order of, I think, two or three significant figures. And I was only missing it by only a couple hundred miles.
Yep. But how would you calculate that, or show it as an example mathematically? I guess you would say. That's a question for Snork.
Well, it started off by he'd realized that we were sitting on a sphere, not just a flat ground. And the part that he was off by was that he didn't realize that the spin of the Earth caused a bulge at the center. So he really wasn't off that much. He did a very, very good job. Let's see. But the important thing was that he realized that ratio of the angles changing was something that he could figure out. And, for the person who figured that out, it was a major foundation for all the rest of the math to come out of it. And so a little step back then meant a lot. And all of this comes together like clues for a detective. It's one more clue.
Yeah.
Okay, we know this is down in Firm. I just thought that was a good start. I didn't know how long I should go tonight.
However long you want. Is there anything else?
I can't see the other chat. If there's any other questions.
Let's see.
There we go.
This actually comes at a very interesting time for us to start talking about circles, because I'm still currently studying for my electrostatics test tomorrow.
Well, I mean, electrostatics is one of the prime forces of the universe, and it also decays by distance with a relationship to its distance. For the test tomorrow, if I double the distance, what is the effect change?
Depends on what you're observing. If you're observing the electric field, you'll see a 4 times depletion in the strength of the electric field. If you are observing the potential, you would only see a half depletion in the potential.
So this is a good study point for you. You got one question down.
Oh, if only E&M was that simple.
Well,
my one saving grace is that I'm not having to do Jacksonian E&M in undergrad.
Yeah, well, I don't even know the term, so I don't know if I forgot it or if I just never learned it. The main forces in the universe, gravity, pulls us down to the ground. We think of it as strong force. It's not. It's way weaker than electrostatic force. It's way weaker than magnetic. Electrostatic force is really strong, especially as you get closer together. So think of Scotch tape. Scotch tape is an electrostatic means of attaching something.
Right.
It actually creates a little electric field that makes it want to stick to things.
Well, that's what's going on with it.
Well, when you get the smooth end, the non-sticky end, if you rub it on your hair, you can easily see it, the static.
Mm-hmm.
And the study of making electrostatic power is tribology. It's the study of friction moving on things. And for a long time, it was thought that would be how to make generators. So it was discovered before being able to make generators out of moving wires.
Yeah. Oh man.
So
conjure up all kinds of generators from that era, like pieces of glass that cats run around in.
So I have a question for you, Snork. So it appears for electromagnetic, whatever you want to call it, coils are pretty much it. Is there any other shape that's more, I guess, efficient or effective?
As you got to remember, other shapes, the closer to you get to a circle, the less other things come in mind. Nature hates a right angle.
True.
So it also hates a square wave. In nature, a square wave is quite catastrophic because, like the Taylor series that I showed you, a square wave would be a whole bunch of those series stacked on top of each other. So given as frequency-wise, the frequencies in a square wave are all of the frequencies in the universe in order to make it perfectly square. And it's the point where they all come together and converge. So, well, I guess maybe not all, but so to have that point of perfect curve, you have to have a whole bunch of perfect chaos. And if you remember the old ignition cars back in the late 70s, when the good radios started getting put in cars, that the spark plugs of somebody that had a really old car zipping on by you go bzzz, because a spark plug is a square wave. It's snap and pop and off again. It's not a perfect square wave, but it's out there. So each time that switch opens and closes, it's actually a whole bunch of frequencies put together, and it's a mass radio transmitter of all those little frequencies. And that's why you get the static from that. A long time ago, when TVs used to go off of the air, off an antenna, if somebody were to bake a cake and run a mixer, it'd screw up everybody's TV set in the area. Electric drills, anything like that, whatever you did, the whole block would know that somebody's making a cake. So I didn't want to get into anything as complicated as multiple waves hitting at the same time. But maybe we'll do that sometime in the future to discuss waves. Because I think you actually can't, math translates to the other fields as well. And even if you talk about ethnicity and race, you can't without talking about waves. Because of how, things transmit kind of in wave function and bounce back as people move across the country and their offspring move in one direction, and pretty soon they're moving back in the other direction. And the whole genetic makeup keeps shifting in both ways. You can't switch to any field that you can't eventually start talking about it in terms of math.
I definitely need to brush up on my math, that's for sure. All right, let's see. Keep it going. I'm gonna get in touch with Dave, see if he's ready.
Okay, I'm looking over here if there's any other question.
Yes, please chat. Please send in questions, because I'm like trying to multitask between my E&M review, this conversation, and checking another chat room I'm in part of. Why do I do this to myself, actually? Like, this is a really terrible idea.
How many more tests do you have to go before you get certified?
Huh?
How many more tests do you have to go? Or did you switch to grad school?
No, I can't afford grad school, man. Like, my grades are not that good. I've only done like 3 months of research and have no published papers to my name. There's the likelihood of me getting into physics graduate school at this point is, especially without a GRE score. Yeah, that's a good luck at Batman right there. But that said, I've pretty much, as far as my teaching certification, I've only got one more test to do. But I'm not going to be taking that till January.
Are you in any classes now?
Yeah, I'm in classes. I'm in electricity and magnetism currently, as well as modern laboratory methods. Basically, the fancy way of physicists saying we wanted to introduce a circuit course so that our experimental physicists don't end up entering the field and frying their faces off when they decide to stick a 2 farad capacitor into their machine.
Somebody thought I had the page had one of the questions wrong. Let's see. Do I have to go back?
Wow.
I think I had a wiki up. He thought one of these looked like it was wrong. I wish I'd still had the screen up.
You should have host. You should be able to share it. Or did you mean like?
I know. I was looking on my page where he's talking about.
Oh.
He said the fifth equation down.
Yep. Looked like a plus sign. Should have been a minus sign.
Which equation was it? Do you remember?
I don't know.
I didn't read through all of these.
Wait, for which equation?
Yeah, that's what I was saying is which equation. Because I popped so many of them up on the screen.
Dominic is just messing around.
Oh. That'd be a pretty good find. Well, anyway, I hope I didn't scare too many people away. Just that there is a use for the math, and math gets a little bit different after high school.
Oh, yeah.
And statistics is math, but it's really a completely different applied math. And statistics warrants a show of its own. You have to use these functions to build statistics. And once you do, you can do some amazing things. It's like you can... I needed a way to have a computer determine if something weird was happening when it had no idea what weird was. And we had no idea what to tell it to look for. So instead, we came up with a mathematical description of something that we thought meant a meaningful change. And we used a formula called the distribution formula to create a ratio of how many standard deviations it was from normal. And typically 97.9% falls within 3 standard deviations. So if something happens that falls out in the 4 range or the 5 range, you can tell the computer, alert me if you see a 4 or a 5, send up warnings if you see a 6. So something definitely has happened if you see a 6. Something important to investigate has happened if you see a 4. And that was a really good function there. And we learned something very important. And we feel it saved an average of 18 American lives a day for the past 26 years, 27 years. How old is Carl, Val?
26.
26 years. I did it the week my son was born, so I could ask him. So there are very important uses for these numbers. And realistically, as the brain forms in human beings, it's forming earlier these days, and we should be able to present more to kids at an earlier age now if we could prevent all the distractions that are happening.
Yeah, that's the hardest part, the distractions.
The only way to present the distractions is figure out a way to make this interesting, and a way to make it seem like it's not worthless.
Yeah.
That you're just going through so much math in the beginning. Seems like just a whole bunch of torture sequences to give you things to do something that makes you fall asleep. And you have to get so far in math before it starts getting useful that, regardless, I mean, algebra, ninth grade, most people never use it. Most people will never stop and write down how many dimes it got versus how many nickels and how many pennies to make how many dollars. Most people will throw it on the counter and start calling it out and say, well, this is what we need. Very few people ever resort to their algebra. But we have to get to the point where most people understand that when to use math and when you're going to have to get serious about it.
Well, I hate to leave it here, but I do need to head to bed early. I'd like to try and do some cooking for future lunches tomorrow.
All right. Well, it was good to have you pop in.
I have the exam in the evening, so best to get rested.
Yep. Good luck in your exam. I wouldn't say good luck. Good, whatever.
Somebody in the chat popped in about the Fibonacci, which is useful along with the golden ratio.
Yep. What are your thoughts on the golden ratio, by the way?
Well, it seemed to be working for the last 2,000 years. Back when the golden ratio started being used, engineers that failed not only to build and build safely, but failed to impress, tended to die. Horrible deaths in stadiums by animals, by having things dropped on them, being ripped apart by horses, you name it. They'd find ways to kill them. So the golden ratio itself, I believe, came about when somebody noticed a way to make it look like the columns were bigger than they were. and they notice curvatures that they could add to things to make things look bigger and taller and more impressive. And it's carried forward to Disneyland. And Disneyland took to the measures that they used to make the buildings look more impressive in ancient Greece. And they changed the height and angles of things on the second, third, and fourth story to make things no bigger than a second story house and still look like they're huge for like their main street, whatever. And when you learn it, even when you know these things, it doesn't look like they pulled these math tricks on you.
I'm gonna have to look at pictures.
AI, as it comes in, we will know what's happening with AI by the math, and AI knows what we're doing by the math. As Google is getting better, as Amazon is getting better, as you're basically searching for things on Google, it's building math equations on you, statistics of who looks for this that also buys that. They know which ads to push to show you so that you're more likely to buy things, and they'll know when to push those ads that's most likely that you'll buy them. So
I've got a question for you. This might be deep, but I feel like math is the universal language. Why isn't life or any life forms based their communications purely on math, or their thinking barely entirely in math?
Well, it's the difference between a language with a purpose and think of it as the difference between when you're programming in your favorite language like Java or whatever. That's not the language that your computer speaks.
Yeah. Okay.
So if you think of it as multi-layered, think of math as the low-level operation, the machine language for the universe. And the upper-level language is what we use to communicate and to the computer through it in terms that we can understand, with the translation to the computer in terms that it can understand. Does that seem like a bad analogy?
That sure fit. Hey, Dave. No, I'm just...
Because the upper level languages are basically just a shorthand.
I mean, yeah, it's a good analogy, but like as far as the answering of the question, it's it's
and
speculation, but
in a way, our natural operating system is kind of math. When you look at this was the psychology class called motivation that looks at how we judge other things. We always things relative to something we know. So everything is always a triangle with what's my relationship to A, what's A's relationship to B, and that's how I form my relationship with B. And if there's tons and tons of relationships, it all gets summed together so that your relationship with C is the relationship all bunch of other points have with C, all parts of influence. And in a way, that summing does become a language of math, low level in the brain. And our language is how we've learned to observe what is going on at that low level math system.
So if we create the ultimate AI, is it going to be based solely on the low level math, do you think? Or it'll just be able to create as many upper layer?
A sufficient AI, when we know it's thinking, will create its own language to think in.
Okay.
Then we're in trouble.
Yeah. All right, Dave, are you ready?
Sure.
All right, so we're going to switch to Dave's channel. Snork, you can stay on RingCentral if you're staying.
I'll stay.
Okay, cool. And then, so everyone in the chat, we'll see you at Dave's channel.
Somebody's mentioning that they can't get into chat for some reason.
Maybe they just have to copy and paste. It's not linking the way
Okay.
that Snork set it up. So yours might be linkable.
Okay.